Hi everyone, this is Purnima Mahalingam and welcome back to the video lecture series on field theory. In last video, we have discussed about vector algebra on basics law of vector algebras and we are ended up with small problem. And now we are going to see what is the next vector algebra. When we can follow that, we can have a problem solving sessions. Okay, thank you. Come, let's go into the topic. Here comes what is an position vector. What is an position vector? Here, first thing is position vector and a distance vector. First thing is for a point P in a Cartesian coordinated system. We know that a point P in a Cartesian coordinated system may be represented as a point P equal to x, y, and z. Okay, the position vector of P. Here the point, the position vector R represents a position vector of point P of a point of P is the vector formed from the origin 0 O to the point from the origin O to the point P. That is a position vector. So the position vector is represented by origin into position. The position vector is represented by origin into position. That origin, we know that x-axis x into ax plus y into ay and z into az. So ax, ay, az as a position vector. And here comes the position and vector and the position and distance vector. Here comes what is the position and distance vectors. Here we can see position vector is equal to 3ax plus 4ay plus 5az. Here were 3ax. So where is an x position is 3. So where is the x position is 3. X equal to 3. What about y? Y equal to 4. And what about z? Z equal to 5. So what here the position? So position point P equal to 3 comma x comma y comma z, 3 comma 4 comma y. So 5. This is what an position vector. And position and distance. What is the distance? Here comes the distance. If we have two position vectors, so or P vector and Q vector. This is for single vector. If we have two position vector, what happens? The third vectors and the distance or vector can be defined as RPQ. If we have two vectors and the third vector is defined as the R vector of both P vector and RQ vector. Okay, here we said this is a point origin 0. What happens? Origin O. Here we have one vector P vector, another vector Q vector. The distance between the P vector and Q vector is represented by the RPQ. The distance between the P vector and R vector is represented by RPQ. That RPQ vector is equal to RQ vector minus RP vector. So RQ vector minus RP vector. This represents the, we have two vectors. The third vector is representing with the difference of the two vectors. Okay. Now next we can come up with small examples of for understanding. We have 2 points P and Q are located at 0 comma 2 comma 4. So that is x, y, z, and then minus 3, that is x, y, z. This is your P vector, this is Q vector, we can consider. So find the position vector of P. First one, we have to find the position vector of P. So next one is the distance vector from P to Q. First, we have to find this is the origin. We have to find the position vector of P, and we have to find the distance between P vector and Q vector. We have to find the distance that RPQ vector, the distance between first we have to find the position vector, that is RP vector, and next one is we have to find the distance between P and Q, and we have to find the distance between P vector and RP vector, and the vector parallel to PQ with a magnitude of 10. So we have to find these four subdivision. First is RP vector. So RP vector, we know that 0 and 2 and 4. That is what? 2ax plus 4ay. Here for we don't have x vector. We have only y and we have only z. This is what RP vector. Okay, so next we have to find the distance vector from P to Q. So that RQ minus RP. This is what RQ value and this is what R value. So minus 3 minus 0, that is minus 3, and minus 1 minus 2, that is minus 1, minus 1, and 5 minus 4, that is equal to plus 1. That is AZ vector, that is AY vector, and minus 3 AX vector. Okay, this is what an distance between P vector and Q vector. Since RPQ is a distance vector, then the distance from P and Q is a magnitude. So the distance from the P and Q is the magnitude of the distance vector. We know that magnitude of we have to find the RPQ magnet. Here we can see the distance D. The distance D is RPQ magnet. That is RPQ. So we know that minus 3 vector, minus 1 and 1. So what is minus 3 square is equal to 3 square is equal to 9, plus 1 plus 1. What happens? So 9, 10, 11. So root of 11 will be getting this answer. Okay. So next last one is, let the required vector can be A, then A vector is equal to A into A vector. Okay. So here the A value is given. When A is equal to 10, then the magnitude of A is what? The magnitude of A vector is what? So the A vector is parallel to PQ vector, then it must have the same unit vector. It must have the same unit vector as RPQ and RQP. So whatever may be, it's a parallel. So this unit vector same if it is RPQ or QP. So that is then that unit vector of A vector is plus or minus RPQ divided by modulus of RPQ. That is plus or minus of RPQ divided by modulus of RPQ. So the A vector is 10 plus or minus minus 3, 1, 1, and finally this value. And this is what an example of a vector. So next is multiplication factor. Here what comes the multiplication factor is, in this can discuss in next video, and I hope you will be understanding what is vector, unit vectors, etc. So thank you so much.